I'm glad to have you aboard with me studying physics. If I have not made a big deal about this, maybe it's because I assume that a lot of people will do this on their own, but you want some kind of journal in which to write formulas that you need to memorize. Memory happens slowly over time, not all at once. So you kind of memorize as you go. By the way, these are great little journals. They're made by bookjournals.com. And what they are is this guy takes books and he takes most of the pages out and puts blank pages in them. I've almost filled this one up, but he puts blank pages in them, and I use them to take notes about physics. And that's what you should do for a subject, is keep a journal with your formulae so that you memorize them as you go. This is, if you know what that's about, give you a pat on the back. You never guess in a million years. Okay, so work, and not like I go to the job every day and my boss yells at me and says, I need that report tomorrow. Not that kind of work. Work in the sense of physics is force that's parallel to the direction of motion. So the direction of motion is this way. So only the force in this direction times the distance that you move something is equal to the work that you do. So I purposely drew a 100 Newton force at an angle of 30 degrees because the work done is not 100 times the 10 meters. It is not 1,000, and the unit for work is joules. It's not 1,000 joules because the force in this direction is 100 cosine of theta times 10, which is about 87 times 10 or 870 joules, roughly, without a calculator. And power is defined as work divided by time. So obviously, if you do the same amount of work in shorter and shorter periods of time, you got more power. A car that has higher horsepower will go from 0 to 60 in shorter times. That's why car magazines say it does 0 to 100 or 0 to 60 in 2.8 seconds for these high-end sports cars. So if I move this box with an 87 Newton force in the direction of motion for 10 meters multiplied by distance, force parallel times distance, I get 870 joules. If I did it in 5 seconds, divide by 5, and that's how many watts of power I put out. 174. And I think they're about 750 watts to a horsepower. I think, if I remember that correctly. But the work is force times distance, and the power is a force times distance work over time. But what is distance over time? It's velocity. This equation is the most often forgotten about equation on the SSAT or in a physics course, that power is force times velocity. So power is work over time or force times velocity, and work is force in the direction of motion times the distance. As a quick example, and then we'll be done with this subject, lickety-split. If I lift a 12 kilogram box, that's lifting it against gravity, doing work against gravity, straight up for 2 meters in 4 seconds, how much power was used? So power is work over time. So I need the work of lifting a 12 kilogram box. What's the force? The force is against gravity, which is mg. That's a hard color to see on the video, I realize. So mg, that's little g. So that's going to be 12 times 10, or 120 newtons of force times the distance, which is 2. So that's 240 joules of work. But I want to know the power. So I need to divide the work by 4 seconds. So I get 4 into 240, which is 60 watts. Kind of like a light bulb. So, and now suppose that I were to lift the 12 kilogram box, I did that straight up at 0.25, a quarter of a meter per second. What power did I use? Well, That's 12 kilograms times 10 to get a force. That's 120 newtons. And I multiply by velocity because power is force times velocity as well as work over time. So 120 times a quarter is 30 watts. So I didn't put out as much power because I lifted it the distance in 0.25 meters per second, a slower velocity than suggested up here. That's about half a meter per second. So work is force times distance, force in the direction of motion times distance, power is work over time, and power is also force times velocity. You know those three things, and you're ready to address most every power problem or work problem that comes your way on the SSATs or in Physics 101.